As we said before, we're going to think about a linear expression as an expression that can be put in the form mx plus b. Remember, every expression does not include an equal sign. And that's why we haven't written y equals mx plus b. That's called a function. In fact, it's called a line. In this case, it's just linear expressions are expressions that look like this. We say that this thing right here is going to be called a variable. This is going to be a constant, and that constant has a very special name. It's called a slope. And then this is going to be the constant y-intercept. And really, it's the y-coordinate of the y-intercept, but that's good enough for now. Let's take a look at some examples of linear expressions. So we'll take a look at our first example. If we had 5x plus 2, here the 5 would be the m, the x is the variable, the 2 is b. That one looks identical to that. Let's take one that doesn't look as familiar. What if we were to do something like 1/4 x minus 4? Well, this thing does not look identical to this because this is a subtraction, that is a positive. But if we remember from our previous lives, every subtraction we can write as the addition of a negative number. And indeed, what we're going to see here, this constant out in front, we're going to call that the m. This -4, we're going to call that the b. Here we've got our variable. And indeed, this is a linear expression because it is in our form mx plus b. Let's take a look at yet another example. And this one, we're going to throw a curveball. Maybe we'll call this -2 minus 4x. We say that this is a linear expression because it is in this form, even though we're going to have to massage it a little to make it look like that. One of the first things that we can do is we can recognize that every subtraction problem is actually just the addition of a negative number. We have this really, really famous rule that I like to call the Missy Elliott rule, which is that I can switch it and reverse it. I can just bring this over to this side and this over to this side because, as a mathematician would say, addition is a commutative operation. In other words, it don't matter if I go first with a -2 and then with a -4, or I flip it around. Once it's in this form, we see, oh my God, here is the m, here is the b. We have a variable with no square power or no third power, etc. That is a linear expression. And then if we wanted to get really exotic, we could actually notice that sometimes linear expressions come in a form that look very, very different from what we're expecting. Claim this is a linear expression. There's something called distributivity, and I like to call this the Lil Wayne theory of mathematics, because I can make it rain. I can make this multiplication rain over that subtraction. In other words, this is going to be 2x minus 2, because I multiplied 2 by x and 2 by -1. I can't forget that I had that little 3 over there. So now I've got 2x minus 5. And then we said that every subtraction was actually an addition incognito. And there we go again. Here we go again. Same old math dog, just a different day. So here is our m, and then here is our b. That is also a linear expression. So all of these are linear expressions because when we started here, there were no equal signs. One of the things that we will get used to is understanding this expression on the left-hand side and this expression on the right-hand side. We call these equivalent expressions. And equivalent expressions are always connected by an equal sign. So on the left of the equal sign, we have an expression. On the right of the equal sign, we have an expression. Once we drop that equal sign in, the entire thing is called an equation. That equation tells us, hey, the expression on the left-hand side is equivalent to the expression on the right-hand side. Quick recap. Every linear expression, we will say, can be put into the form of a line. In other words, mx plus b. There's no equal sign because mathematical expressions do not include equal signs. Let's keep going.